Movement observations and environmental data are collected from different sources. For example, we collect movement observations using GPS tracking and record environmental variables using satellite imagery. Therefore, these datasets come in different formats and structures, and they are often collected at different spatial and temporal resolutions. For instance, environmental data are often collected in raster format at various resolutions, while movement data are typically recorded as point locations. GPS tracking primarily provides information on the locations and times when the individuals are observed. Rarely, we have information on the surrounding environment of the moving individuals in GPS records. Unless we use multimodal sensors that are capable of sensing ambient environmental conditions such as temperature. To analyze the association between movement and the environment, it is necessary to link movement and environmental data together. One method to achieve this is through a data annotation process. Trajectory data annotation is an important process in movement research, enabling us to link movement data and environmental data and other contextual variables. In movement ecology, trajectory annotation enables researchers to enrich animal location observations with environmental variables such as habitat type, weather conditions, and information about land and ocean characteristics where the animal moves. Trajectory annotation process involves attributing environmental data to each tracking location along the movement path of individuals. This provides valuable context and an enriched dataset for researching animal behavior and habitat use. Trajectory annotation is often conducted through spatial-temporal interpolation of raster environmental data at GPS point locations and times. Spatial-temporal data interpolation is a GIS process used to estimate values of unsampled locations and times based on known data points in both space and time. Here, the values are those environmental variables that need to be interpolated at the time and location of GPS observations with unknown environmental conditions. The spatial-temporal interpolation process involves two steps. First is spatial interpolation, to interpolate values across the space for each time point. Second is temporal interpolation, to interpolate between time points at each spatial location. For spatial interpolation, different techniques are used. These techniques include linear interpolation, bilinear interpolation, and inverse distance weighting or IDW. Temporal interpolation is often conducted using a linear interpolation process. Linear interpolation is a method used to estimate a value between two known points on a linear scale using a linear regression model. It assumes a straight line relationship between the 2 points. Bilinear interpolation extends the concept of linear interpolation to 2 dimensions. It is used to estimate the value of a function at an arbitrary point given the values at 4 surrounding points in a rectangular grid. The process involves 2 steps. First, performing linear interpolation in one direction, for example, horizontally, then performing another linear interpolation in the other direction, for example, vertically. Inverse distance weighting estimates values based on the weighted average of nearby known points. The weight is a function of inverse distance between the points raised to a mathematical power. The power parameter lets you control the significance of known points on the interpolated values based on their distances from the output point. By defining a higher power value, more emphasis can be put on the nearest points for interpolating the unknown point. Depending on the type and resolution of the environmental dataset, we might choose to apply a different type of interpolation technique to conduct trajectory data annotation. Using interpolation, the environmental variable is estimated for each GPS point along the trajectory and is annotated to the point as an attribute. As a result, an enriched trajectory data is generated, often in a CSV format, which includes not only information about the location and time of movement observations, but also the environmental variables associated with each observation. One example of trajectory data annotation is the Environmental Data Automated Track Annotation System, or in short, ENV-Data, which is integrated within MoveBank. MoveBank is an open portal for animal tracking data. ENV-Data automates the annotation of movement trajectories with ambient atmospheric observations and underlying landscape information. Trajectory data annotation using systems like ENV-Data enriches movement data for further analysis in GIS, enabling researchers to, for example, investigate the relationship between animal movements and environmental conditions, or study habitat selection and use by animals, or analyze the impact of weather patterns on migration routes. Or we can investigate the influence of landscape features on animal behavior and survival strategies.